Welcome to the first video in this series. We will be building an AI that can play a video game just like you. Let's look at the goals of this project. First, we need to teach a computer to see our game screen and health bar. Next, we will use OpenCV to process the data in a way a computer can understand. The computer will use visual targets just like a human to determine the health of the player. As our character takes damage, our AI will be able to see the changes. Finally, our AI can perform actions like healing or running away. Or dying. Okay, welcome to part 1, screen capture. Today's agenda is first we are going to learn how to capture the pixel resolution of your display. We're going to learn how to capture an image and store it into memory. We are going to process that image to make it ready for use with OpenCV, Python's computer vision library. And finally, we're going to display that image live so that we can see through the eyes of the computer. So let's get started. Okay, so fire up the IDE or text editor of your choice and let's get coding. So let's create a new file and let's call this AI_screenCapture.py. This is going to contain all of the screen capture parts of our AI. So first we've got to begin by importing some libraries that we're going to be using today. The first library we're going to be using is MSS. The next library we're going to be using is PyAutoGUI. We're going to import the CV2 library. This is the OpenCV library for Python, and I like to call that CV when I code out of habit. You can call that CV2 if that works for you. We're going to be bringing in the NumPy library as NP. And last, we're going to be using one of the standard libraries, Time. Now, if you don't have all of these libraries installed, let me show you really quickly how to do that. So you're going to fire up your terminal. You're going to use pip, which is Python's package manager, and you're going to do pip install MSS, which will install the MSS package. Mine's already installed. You can do pip install PyAutoGUI. You can install OpenCV-Python. This is going to be that CV2 library, NumPy. And you will see that all those packages are already installed for me. So make sure that those are on your system or virtual environment, and then we can get started. Okay, first let's display the resolution of our display in pixels. And to do that, we're going to use PyAutoGUI. So we'll create two variables, width and height, and that will be equal to PyAutoGUI.size. And let's print to the terminal screen resolution. And let's convert the result to a string. We'll say, or I guess we can do this. We can say width plus string w plus height string height. So this is just going to print out our screen resolution in width and height. Let's put a space here to make that a little bit more clear, and we can run our program and make sure that that's working properly. And you can see that my screen resolution is 1920 by 1080. Yours may be different. That's totally fine. Okay, next we're going to begin on our image capture. So first we want to create a variable called image, and we'll set it to none. And this is where we are going to be storing our screen capture in memory. Let me close this so you can see a little bit better. So we'll initialize that at as none. And we want to use the MSS package to capture our screen. And it's going to take some parameters which we can define as the monitor resolution. So we'll say monitor equals, and we're going to create a dictionary. We'll say top is going to be 0. So the monitor top left-hand coordinates are 0, 0 pixel coordinate. And my 1920 by 1080 monitor will increase in the X direction. This will be plus width. So this right-hand side would be the 1920 X coordinate. And the top of the monitor would be 0 in the height, or the Y coordinate, and the bottom would be the 1080. So that's how we're going to initialize our screen capture. We want to inform MSS, where do we want to take a picture? Is it just going to be a small part of the screen, or do we want to grab the whole thing? And in our case, we want to grab the entire monitor. So we're going to say the top is 0. We're going to say the left is 0. And we're going to say the width of our capture is going to be our width that we just pulled out with PyAutoGY. So in my case, that'll be the 1920. And finally, height is going to be H. Okay, so we can use this to feed into MSS. Next, we want to say width, MSS.MSS, oops, as SCT. And we are going to capture the image into that image variable that we created above. We're going to say image is equal to sct.grab. And we want to set the monitor to the monitor we just defined above. So what this is going to do is this is going to grab a screenshot, and it's going to grab the rectangle that we define here. We want to define the top left is 0, 0, and the bottom right, or the width and the height of that rectangle should be down here. So that way we get the entire screen. Now let's say you just wanted to take a small portion. You could actually say, well, I just want to start at 500, 500, for example, and that would shift your corner down here, and you would end up capturing just a portion of the screen. So that may be useful in some applications. But for us, we want to capture the entire monitor. Okay, so now the image is stored in memory, but it's not ready to be used yet by OpenCV. We need to do some processing. The thing that we need to do is we need to convert this into a NumPy array. Luckily, that is extremely easy, and it can be done in just one line of code. So we're just going to overwrite that existing variable, and we're going to say image equals np.array image. So this is going to take that data, and it's going to convert that into a NumPy array. Now, in some applications, we would need to convert from RGB to BGR, because many screenshot applications and most applications today use RGB color space. Luckily for us, this function actually captures in BGR. So the blue, green, red instead of red, green, blue. And that's convenient because OpenCV also works in BGR. So we don't need to do the extra step of converting our color. If you were following along in some of my other tutorials where we used PIL, Python's image library, for screenshots, that captured an RGB color and it needed to be converted. So if you're not using MSS and you're following along, but you're trying a different way of screen capture, make sure that you convert it to BGR if it's not BGR. Otherwise, your color channels are going to look a little bit wonky. Okay, next we want to save this as a smaller size image so that we can display it. If we display it as a full screen size, it'll be kind of confusing. So let's create a small version of this image, and this will be the first time we're using our OpenCV library. So we're going to say cv.resize. This will resize an image. And we're going to first pass in our matrix. So this is the image. So we want to pass in our image. Next, this is where we could pass in a size. Alternatively, we can pass in a ratio. So what we're going to do is, instead of saying, I want to resize this to 500, 500, that's one way to do it. But instead of saying that, I don't really want to calculate the pixels. I'm going to pass in 0, 0 as the size, and that's perfectly fine. And next, I'm going to pass in some parameters. Fx equals 0.5. Fy equals 0.5. And what this is going to do is this is going to take the current resolution and multiply it times that scalar 0.5, which is going to basically resize this image to half size for us. The alternative way would be to actually take W, divide by 2, do a floor so you can convert it to an integer and put that in here. That would work too, but this is a little bit more convenient way if you just want to work with a quick scaler to scale your image. Okay, next we want to display this image on the screen. We want to see what the computer is seeing. So to do that, we just have to put in one line of code, cv.imshow. And first we have to create a window name. This is not the image as the first parameter, it's the name of the window. So we're going to call this window Computer Vision. And now we're going to pass in our matrix. Now we're going to pass in our image. Let's pass in the small image so that when it creates this window, it's a small scaled down size instead of the full 1920 by 1080 in my case. So if we run this program, we're probably not going to get a result. So let's see what happens. Okay. And it exited and we didn't get anything. So what happened? Well, don't worry, nothing is wrong. The program ran so fast that the window appeared and disappeared so fast that we didn't get a chance to really see that. So what we need to do is we need to introduce a delay so that we can actually see the screen. And CV also provides a function for that. And we're going to call cv.waitKey. And first let's pass in 0. Passing in 0 will cause the program to wait until any key is pressed. Wait indefinitely. It's almost like a pause button. So we'll use this first to kind of check if our image is appearing properly. And next, after we show this image, we also want to make sure it's destroyed properly. So let's also call one last function before we run this, cv.destroy all windows. This will make sure that when the program exits, all windows that are open in OpenCV are closed. So let's run this now. We should get a screenshot of my current desktop. And there we go. We have a screenshot at half size with my current desktop. When I hit a key, it disappears and the program exits nice and clean. That's exactly what we want. Okay, next we want to implement live screen capture. We don't want to just take one static image. We need our computer to see just like we see constantly. So how do we do that? Well, it's very simple. First, what we're going to do is we're going to take all this code that we wrote and we're going to do it over and over and over and over again. And the easiest way to do that is we're going to put this in a while loop. And we're going to say while true. And let's tab over all of our code so that it's inside of that loop. So this code is going to run forever. Now if you run the program now, there's no way to break that loop. So you're going to have to Control-Alt-Delete or hard kill that program. So don't start it just yet. So this is going to run over and over and over again, and there's going to be a pause button every time. Well, first, we don't want to have a pause. We want this to happen over and over and over again so that we can see the computer updating live. So instead of 0, we can change that integer to a delay in milliseconds. So let's add a 1 millisecond delay, and that will cause this while loop to run. It'll run one iteration of the loop. It'll reach the wait key line. It'll pause for 1 millisecond, giving a chance for that image to render. And then it will go through the loop again, and it'll keep doing that over and over again. And we also don't want to destroy our windows every time we run through this loop. So we want to take our destroy all windows and take that out of this section here. That will be the end of our program. Okay. So next, we need to make sure that we have a way to end this loop, otherwise it'll just go on forever and ever. So what we can do is when a user presses the key, we can store that value in a variable called key. So we'll say key equals cv.waitKey. So during that 1 millisecond delay, OpenCV is going to check, was any key pressed? If a key was pressed, it's going to store the value in key. And what we can do is we can do a if key equals ORD Q break. So what this will do is, first, when we reach the wait key, we have a 1 millisecond delay. If a key is pressed, it will store that value in key. Next, the program will check, was the key that was pressed the Q key for quit? If the key that was pressed was Q, it will run this line of code, which is break, breaking the while loop and exiting the program. So let's run this and see what we get. And there we go. Very cool. We now have a live screen capture of our desktop constantly being updated. And if I press the Q key, the program exits. So let's do one last thing. It would be nice to check the performance of this. And to do that, we're going to use our time package, and we are going to check how many frames per second is this running at. So first, we're going to initialize a starting time. We're going to say t0 equals time.time. And we're going to say n frames equals 1. And what we're going to do is, every time this loop runs, every time we go through this loop, we are going to increment our frames by 1, the total number of frames that were shown by cv.show. So this will be frame number 1. The next loop will be frame number 2. The next loop will be frame number 3, and so on. And what we can do is we can print, we can have a elapsed time. So we'll say elapsed time equals time.time minus t0. So this is the total time that has elapsed since we started this program. We can then calculate our frames per second by doing a simple calculation of n frames, how many frames have been captured, divided by the total elapsed time. This elapsed time is in seconds already, and of course we have frames. So now we have frames per second. And we want to make sure that we increment frames every time we go through this loop, otherwise we won't get the right calculation. So now when we run this program, we should see a live screen capture along with a frames per second FPS report to give us an idea of our performance. Let's try it. Okay, I think I forgot to print that out. So let's add another line and do print FPS, and let's do string FPS. So now we should be able to see our frames per second. And there we go. My current implementation is running at about 20 frames per second. That's not too bad considering the fact that I'm also recording this video, so that puts extra tax on my system. Hopefully you're getting a little bit of a higher number, but this is a acceptable number for the use of our purposes of creating an AI to play a video game. Alright, well, thanks for watching this video. I'll see you in the next one. Please like and subscribe. I would really appreciate it. And have a great rest of your day.